This is the fourth video on chapter 48, Solids of Revolution in Volume. And we are going to do example 359. We're going to do part D. So this will be the final part of example 359. What we did in part C is we took our region and we rotated about the line y equals 0, or x equals 0. So we rotated it about the y-axis. That's what we did in part C. In part D, we're asked to rotate this region around the line x equal to -1. So we're rotating this around the vertical line x equal to -1. And so there are a couple of different ways to do this. I'm going to set this up a particular way. So what I'm going to do is I'm going to say we don't really have a formula for rotating around the line x equal -1, but we do have a formula for rotating something about the line x equals 0, or the y-axis. And so we have a formula for that. So what I'm going to do is I'm going to take this picture and I'm going to shift it. Instead of rotating this region around the vertical line x equal to -1, I'm going to move it 1 unit to the right and then rotate it about the y-axis. It creates the same object, and that same object has the same volume. The reason I'm doing that is to use the shell formula. So how do you shift a function to the right? Well, you substitute x minus 1 for x. And so the fourth root function right here, y equals fourth root of x, we substitute x minus 1. This shifts the fourth root function to the right 1 unit. Same thing with y equals 1/8 x. We replace x with x minus 1. This shifts the function to the right 1 unit. So now we're going to take this region, revolve it around the y-axis, has the same volume as, well, this region revolved around the line x equal to -1, and now we can use our formula. So we integrate from 1 to 17, 2 pi x, and again, we have a larger object and we have a smaller object. And we're going to subtract the two volumes like we did in part C. So we have our larger object, so we have 2 pi x times this function, and then we have 2 pi x times this function. We factored out the 2 pi. We factored the x out of the functions, but we can't out of the integral. And so it's the same idea. So 2 pi x times this function, if we integrate that, that gives us the volume of the larger object. And then if we integrate 2 pi x times the 1/8 times x minus 1, that gives us the volume of the smaller object. And then we take the volume of the larger object minus the volume of the smaller object, and we can write that as this integral here. Simplify this a little bit, and now we have an integral to calculate. It's not going to be a fun integral, and our numbers aren't going to be very pleasant. What happens is we're integrating -1/8 x squared plus 1/8 x. This part here is just a polynomial. That's not too bad. This part here will involve a substitution. So we have an x, and we have a fourth root of x minus 1. So you'll let your u be x minus 1. Your du is dx. And so if u is x minus 1, then x is u plus 1. And so you'll make your substitution here. Remember to also change your limits of integration when you're doing a u substitution with a definite integral. This part will not require a u substitution. So what I would do to finish this is I would calculate the integral of this part first. Then I would calculate the integral of this part, add those two together, and then multiply by 2 pi. So I would do this in steps. I would break this down into two different integrals at this point. When you're done with the two different integrals, add those together and then multiply by 2 pi.